Hey AAF students, welcome back. So in this video lesson, or it's certainly not a lesson, I'm not sure why I just called it that. In this video, I am going to help you to make your little review book for Unit 4, which is our last unit of marking period 2 and semester 1 this year. So as you have done in all of the 3 previous units, please make sure that you've made your little review book, right? And so that's what we're asking you to do. This is just like it was in Unit 3. This is actually going to be factored into your test. So please take it seriously as it is something that is beneficial to you. So as you notice, just like in Unit 3, I'm not actually in the video showing you how to make the little review book. Right, and so I explained in the last video that in the Unit 3 little review book video that we were kind of like going to wean you off of it. And at some point, you might just get the PowerPoint and it's all you to go back and review. So that rhymes. So if you don't remember how to make the little review book, take a moment now to maybe stop this video and maybe you want to go back and watch the one from Unit 1 or Unit 2 to remember how to make it. So let's get started. Unit 4, and then maybe you want to write your name. Probably a good idea. And then you can add this to your bag or your whatever you are, wherever you're keeping all your little review books, which I hope that you are doing. So this unit was about quadratics. Maybe I should have added that in there. Right, all about quadratics. And you can draw your pretty pictures as we so enjoy seeing. So I'm going to go a little bit out of order with this. So I'm going to start with, even though this isn't what we started with on the unit, I'm going to start with this on the little review book. If you choose to do it in a different order, that's fine, as long as this content is here. So I started off with vertex form, and some things that you might want to remember are here, or maybe you want to write actual vertex form. Maybe you want to say that this is also called graphing form, right? And you have y equals a times x minus h squared plus k. You can say what a represents. You can say what hk represents, right? When I'm saying solve for a, right, what if we knew the vertex and we knew a point? How could we solve it? I would probably give myself an example here, right? In fact, maybe I would eventually get to, I would come up with vertex or graphing form, and I would say, okay, given, right, I would do one example on this, and given that the vertex is at blank, or maybe you're starting with a graph, even better, right? The vertex is at blank, and it passes through this other point. You can solve for A, and then you can talk about what A is, what H, what K is, what it means. I would maybe include things even like the transformations, right? That's probably a good thing to talk about here, right? The transformations from y equals x, right? Are you someone that commonly says flipped? Can you change that to saying things like it's reflected over the x-axis to be a little bit more precise? Maybe you're really stuck on the word dilation, which is a great word, but maybe you're translating that. Maybe you're transitioning a little bit to think about that's actually the vertical stretch or the vertical shrink, right? How do you find the x-intercepts, right? And then I would definitely practice graphing, labeling, and identifying the key characteristics. Okay, and then I also have a page over here. And so I'm just writing some stuff. I'm obviously adding more thoughts in here because there's a lot you've learned about vertex form. But I feel like an example would be something that's useful so you know how it's applied if it's something you're coming back to. Like this is a unit and these are topics that will come up so much in your math career that this one is going to be super useful to you. So the next one that you have is standard, which is sometimes called general form, right? And this is y equals ax squared plus bx plus c. How do you find the vertex? X of b equals the opposite of b over 2a, right? Maybe you even want to make a note that to go from here to here, you would have to complete the square. That's going to come up later too. Maybe you want to add that in for your notes. X-intercepts, right? So you have different ways of doing this. Maybe you're going to factor it. Maybe you're going to use the quadratic formula. Oh, that's right here. Right? This is a good one for quadratic formula. So even if there are no x-intercepts, there are always going to be solutions. And then again, graphing, labeling, and characteristics. And you can add more to these. So then I did a page on just transforming between forms, which there was a whole video on. And so I kind of just left this open of how would you go from factored to vertex? How would you go from vertex to factored? How would you go from factored to standard? How would you go from standard to factored? Standard to vertex? Vertex to standard, right? And so I would probably approach this with a few examples, is probably what I would do. Right? And remember, not everything can be written in factored form, right? So these are the ones that like not always it can happen. You can write anything in vertex form and in standard form, right? That's totally possible. Maybe you're only going to be writing something in factored form for the purpose of this class if your intercepts or your roots are real and rational. And then, so I kind of went a little bit out of order there. I started with the graphing and the different forms. And then I did, so it's almost like completely backward, how we talked about solving. Right? And remember, some of us made errors on that quiz about how you solve by factoring. Right? This shouldn't stop. We need to use the zero product property here. And thinking about when you're solving over the set of complex numbers, if I get something like the square root of -10, I'm not stopping. I'm saying that's I root 10. Right? And knowing that idea, like this is not enough. Right? You used to say no real solution because there's no intercepts. Right? But there's no real solution, but there are complex solutions. Okay, and by completing the square, by factoring, and by quadratic formula, and with this comes discriminant reasoning. Right, and solving can even mean I'm figuring out, okay, 2x squared plus 9x minus 5, where does that cross the line 7? I can use discriminant reasoning here. I can subtract 7 from both sides. And then I can find, oh, I can actually divide by 2. No, I'm not going to. I can use discriminant reasoning right here to figure out, does this parabola ever cross this line? Right? Oh, b squared, 81. Oh, goodness. Oh, my gosh. Minus 4 times 2 times -12. 12, 24, 36, 48. 48 times 2 is 96. Yeah, that's definitely positive, isn't it? 177, right? So, oh, this parabola, this quadratic is going to cross this horizontal line twice. They're not going to be at real rational, they're not going to be at like rational places, but I would know that it is going to intersect in 2 places. So I can use discriminant reasoning to actually figure that out. I kind of just spiraled in this one, sorry. So, okay, maybe save some of that for this page, right? So figuring out how many and what types of solutions using the discriminant. And remember that b squared minus 4ac is the discriminant. It doesn't include the radical. That is a common error that I've seen. And then as I just gave an example of this on the last page. So this is, I'm completely backwards, right? And this is actually how we started this unit, with complex numbers and knowing operations with complex numbers. So we defined I. We simplified I, knowing that I, we were just represented as I. I squared is real. I to the third is imaginary. I to the fourth is real. Right? And then I to the fifth, where that is the same thing as I, right? And knowing how you can figure that out. So if you have something like I to the 703rd, well, what is that the same thing as? Well, let's see. If I divide it by 4, oh, that goes in once. 4, 3. Is that a 0? Yeah. That goes in, 4 goes into that. 8, nope. 7 times is 28, which is going to be 223. 4 goes into 23 5 times 23, so my remainder is 3. Oh, this is literally the same thing as I did the third, which is negative I. Whoa, right? And so knowing how to simplify that, as well as adding, subtracting, multiplying, and dividing, which was really just simplifying. And our goal for all of these is to express them as a plus bi. So when you're dividing and you have something like 28 minus 7i over 3 plus 4i, this is not a plus bi. Like, our goal is to express it as a complex number. And so we would have to multiply by the complex conjugate, 3 minus 4i, 3 minus 4i, right? And what's going to happen here is it works kind of like difference of squares. So I'm going to end up with a squared plus b squared, so 25 over that. And here I would do double distribution. Remember, FOIL is not a verb. It's a way to remember how to do double distribution. And then plugging in, and this was actually not assessed yet. We did it in the Flipgrid. Plug in complex solutions to verify, right? So you can figure out, oh, let's see, you've got y equals 2x squared minus 5x plus 4, and you're saying, is 2 plus 3i a solution? Right? And you're plugging it in and you're showing your work. I feel like we were very accustomed to like, oh, I know this should work, so I'm not actually going to show that I squared it. Right? And some can be more complicated than others, and it's really, really good to practice ones that are more complicated and more involved and rigorous, which many of you guys experienced on the Flipgrid. Because then you're more prepared for it if we throw it your way, right? So you can practice something that's like involving a square root. Like, what happens if I plug in 2 plus I root 3 over 5, right? And would I be able to successfully square that, right? That's really like practicing stuff like that so that you're prepared for it when it's placed in front of you. And then finally, on the back, we've left some room for modeling and applications, which is how we just closed this out. For modeling and applications, we should know how to use a calculator. And that is useful information to put onto this little review book. However, no calc on the test, right? That's something that we've taken away because we're not in person. So you're not going to have to spend the time to maybe generate a regression model, right? Or plug it in and generate the vertex. However, given a word problem, would you know which piece of information to find, right? Or given the linear, or I'm sorry, not linear, the quadratic regression model already generated, would you know where to plug certain things in and how to use units and how to define your variables? So you need to know the process and how to do it and how to do applications, but you're not going to have to sit there and like generate it on your calculator for this assessment. It is important that you know it in the future, and that's why it's part of videos and lessons, and we do want to teach it, but it was something in this setting that we decided we wanted to remove to take something off of your plate. So, as a reminder, in your video that you're submitting on this little review book, we should see your book, right? Just to emphasize that. We don't just want to hear you. That's great. We want to. We want to actually see it. So show it to us. Show it to us in the video. We should also hear you. And we want to hear you talking through this. We do really believe that it is such a benefit to talk through things, and that's something that you would have in the classroom if we were doing these in the school building. And so we want to give you an opportunity to do that so that you are talking through things. And if you can explain what you did, you know it, right? That's a really good way to review. So to emphasize that. Finally, this little review book should be added to your your folder, your bag, wherever you're keeping all of your little review books for future reference. It is not something you're going to be using on this assessment. It is something you're using as a tool to review and practice in preparation for this assessment. So that being said, if you have other things that you want to add on to here based on what you may need or want, please, please, please feel free to do so and use your textbook and the resources to come up with different problems and practice and have fun studying. Thanks everyone for watching, and we will see you next time, which I think is next semester. Bye guys.